Hello everybody, today I'm going to be going over quadratic inequalities, more specifically solving them. And the first thing that we have to understand is the key steps and the key idea. Now, quadratic inequality is where we have that quadratic and it has something like a greater than or less than here that makes it that inequality. In this case, you need to always find the critical roots by solving the quadratic first. Then you need to test the points or use assigned diagrams on the intervals that are created by the roots. Then we also have the discriminant, and this is essentially what lets you see whether the real roots exist or not and tells you what kind of solutions that you are set to expect. So let's first of all do this with our first example here. Now this is giving us a quadratic and it's saying that it is greater than 0. And it wants us to solve the quadratic inequality. So the first thing I'm going to do is factor this out. What multiplies to 6 and adds to negative 5? What two numbers? Well, first ones I'm thinking of is 3 and 2, or sorry, negative 3 and negative 2. And those multiply to 6 and add to negative 5. From here, our critical root values become x equals 3 and x equals 2. And what we do here is, upon getting these, we make our sign analysis. Now this is by using a nice little diagram of the quadratic, and we have to put our little values. So here's 3, here's 2, draw our quadratic, and since the value's up, positive value, so it goes like that. Now, upon being greater than 0, it means anything above the x value, so it's all of this. Therefore, the solution is XER, such that x has to be greater than 2 and less than 3. Now this is x squared minus 4 is less than or equal to 0. So this time it's a little bit more different because it actually includes the equal to. From here you might notice that this is a difference of squares. And to solve that, we can just do our difference of squares formula to get x plus 2 and x minus 2 is less than or equal to 0. Then from here, we can solve it. X equals negative 2, x equals 2. From here, we can put these on our little quadratic. Here's negative 2, here's 2, and there's our quadratic. Now from here, it's asking us where it is less than 0. In this case, that is right here. So our value is going to be XER, such that x is less than 2 and x is greater than negative 2. Now if we look at the answers, we have to make sure it's greater than or equal to, and yep, x is greater than negative 2 and x is less than 2. So here's our next example, but this one uses a slightly different property, and that is multiplying every single term by the negative. The reason why we do this is that we cannot directly manipulate the negative x squared here. Rather, we have to multiply everything to change its sign, and that's another crucial aspect of these quadratic inequalities. So we multiply everything by negative, we get x squared minus 3x minus 4, which is greater than 0. From here, we can do a quick little quadratic solve, and I believe that it is, or sorry, not quadratic solve, but we can do x minus 4, and I think this is x plus 1, greater than 0, x equals 4, x equals negative 1. Those are critical points, and therefore we can put a negative 1 there, or 4 there, draw our thing, make it greater than 0, which is these ones. So where is that? That's x is less than negative 1. X is less than negative 1, as well as x is greater than 4. And here, if we look, yep, x is less than 1 or x is greater than 4. Now here's another problem, and this one can be solved in a much more unique way, but it's mainly the same exact thing. Here, what needs to be done is that, first of all, we need to factor it, so x minus 3 again, and 2x minus 1, which is greater than or equal to 0. This is going to be done factoring. You can do the multiply by you can do the idiot's method if that's taught to you, or whatever method's taught. This is x equals 3 and x equals 1 over 2. Since it's greater than or equal to 0, we can have our little values here, 0.5 and 3. again show it where it's greater than 0, which is up here. So XER such that x has to be greater, or sorry, x has to be less than or equal to 1 over 2, and x has to be greater than or equal to 3. Now, this is another problem, and this is where the discriminant is equal to 0. And this one I have to show you is a little bit, pretty much the exact same thing, but with a little tiny nuance. Now, what you have to understand is that this is a perfect square trinomial, meaning that has one only answer to our discriminant. Now here we can understand that it's x plus 3 and x plus 3. To factor it out, greater than 0, x plus 3 squared is greater than 0. So our solution is x equals negative 3 and then x equals negative 3. And if we draw a quadratic for this, we have a negative 3 down here. Sorry, negative 3. And in this case, since it says it's greater than 0, I want you guys to think, what is the true solution to this? Now, greater than 0 means everything around this. But what it does not include out of all of these is this value except. So what you can say is that XER except such that x cannot be equal to negative 3. So that's our tiny little thing here. Since if it is said greater than or equal to 0, then x could really be anything, but it does not actually include it since it says it's only greater than 0. So that one is something that you have to look out for. I'm pretty sure I fell for this personally in one of the tests where I had this, so look out for that. Now here is another one, and this is where we finally get off with it. Here it says x squared plus 4 is less than 0, and this is the same exact thing but a little bit more different. Well, if you don't know, this is actually unsolvable, so x cannot equal to any real number at all. And the reason why we know this is by applying the discriminant. So let's do that right now. Our b value is 0 minus 4, a is that, and c is 4. In this case, negative 4 times 4 is 16, and this is less than 0, meaning that it is not able to be used, and since that means that the parabola kind of looks like this, it does not touch anything, so we cannot actually use it and solve the quadratic. Now, that is all we have. There's a lot of worksheet and homework for you guys to do, so be sure to do that. I went into the basics, but hopefully you guys should be able to understand the rest, as these are pretty much the only tools that you have to know for quadratic inequalities.